Okay, our objective for section 4.2 is to write equations in slope, intercept, and standard form from a given scenario. Yesterday we talked a lot about slope-intercept form. We also rearranged equations that were in a different form to get them into y equals form. Okay? Bless you. So this is a really good transition because we're still going to be seeing things in y equals mx plus b form, but now you're going to learn a new form. Okay? And we're going to be writing these equations from a scenario, at least starting to learn how to do that. Okay, first thing I need to go through is the very top, there's a box at the top of your notes. I need to explain this. There's not much writing to do, but I need to explain this. So it says here, linear functions and slope. The first thing you need to fill in, and I have it underlined as to what you need to fill in. The highest exponent on the x variable is a 1. So if it's a linear function, the largest exponent is going to be a 1. So let's go back in time for a couple months ago here. If it was a quadratic function, what did the highest exponent have to be? Andy? Good. If it's a quadratic function, the highest exponent has to be a 2. You guys and girls remember that from September, and that was our parabola graph. They went this way or they went this way. If it's a linear function, the highest exponent is a 1. Okay, Gigi? Good. A cubic function is a 3. You actually won't learn how to graph those until Algebra 2. So you're ahead of us here a little bit. Okay, and I already said this. The graph is a straight line. Last year, we learned how to graph these, so I'm not worried about you guys graphing them. I want you to be able to translate a scenario into an equation and vice versa. The whole point of this chapter is application, applying slope-intercept form to a scenario, taking a scenario and translating it to an equation. So you need to understand what the slope means, what the y-intercept means. Now, I'm saying that much to you is because you already know the slope and y-intercept. You've seen them on graphs. You know how to graph them. Okay, but we need to translate it to a situation now. Okay, there's two different types of linear equations. So the first type, you know, we talked about yesterday more, is slope-intercept form. So just fill that in, again, what's underlined. It has next to it y equals mx plus b, which is already typed for you. This is the graphing form. So that's not changing from last year. You're still graphing it as y equals mx plus b. Nothing is changing in regards to how you graph a linear function. Here's what's different. The second one, let me make this a little bit bigger here. Second one is standard form, okay? Standard form, and actually typically the A, B, and the C are capital, but it doesn't matter. Standard form is AX plus BY equals C. You'll see it in this form a lot when you're using matrices. Your book in chapter 4 is going to put it in that form to make it more difficult for you in regards to graphing. So AX plus BY equals C. A, B, and C are always a number, and they have to be real numbers. Okay? A, B, and C are always numbers. They have to be real numbers. A and B cannot be fractions. I need you to underline or circle. A and B cannot be fractions. The main reason is for whenever you get to matrices in Algebra 2 and a little bit in geometry, no fractions, which includes decimals. So don't say to me, what if I have a decimal? That's the same thing as a fraction. I know you guys know that. So no fractions. The next big thing you need to remember for standard form is A can never be negative. This is something that you'll see the proof of and the real reason of in Algebra 2. You'll do a lot more with this. But for now, for Algebra 1, you need to remember the A cannot be a negative. Also, A and B cannot be a fraction. That includes decimals. Okay, so one more time, standard form is just another form for a linear function. This slope-intercept form is the form we use for graphing. Okay, does anyone have questions on either one of these forms before we start our first problem? Okay, without looking at your notes, who can tell me what standard form is? Without looking at your notes. Gigi. You guys sound excited. No, I'm just kidding. AX plus BY equals C. Okay, who can tell us something you cannot have in standard form? Well, that was like a half hand. Okay, A cannot be negative. Okay, you're good. You can stop there. Eric, what's the other thing? Good. A and B cannot be decimals, which is the same thing as cannot be fractions. Okay, is everyone clear on that? All right, example 1. Don't try to go ahead of me, okay? Stay with me. I know some of you guys really like to. Let me at least get through the first example and the full thing, and then you can start to go a little bit ahead of me. Above number 1, okay, wherever you have room, maybe above the directions, I know that these are kind of squished together. I want you to write down blank depends on blank. Okay, don't answer it yet. You probably remember this, but for now, write down blank depends on blank. And then one more thing before I read it. Somewhere else near that, but not right underneath it, write down x equals blank, y equals blank. We're going to do that setup for every problem. Okay, one more thing before I read it. Think back to September when we talked about functions in Chapter 9. What always depends on what? Raise your hand if you remember. Back to functions. What always depends on what? I'm impressed, about half of you. What always depends on what? Brian B? Close? Good. Y always depends on x. Write that down. Y always depends on x. Okay, another question for you before I read it. I keep saying that. What's another word for y, or what are a couple other words for the y variable? Luke B? Okay, range? The other one? Good. Range, dependent, and then the other one is the opposite of input, output. Okay. Gigi, what's another name for x? Domain. Okay. And? Good. So domain, independent, and input. Everyone remember those? We did those last year and this year. Okay. So let's read the problem. Michael has run 3 miles this week, and he runs 2 miles every day. So I'm going to say this again. Michael has run 3 miles this week, and he runs 2 miles every day. What depends on what? Don't think about x and y. In that scenario, what depends on what? Jared, what do you think? Awesome. Miles depends on the day. In other words, how many total miles that he has run or ran, whatever's the correct one, depends on what day it is. So remember, y is your dependent variable, x is your independent variable. X is something we can't control, okay? We can't control that it's Tuesday today, right? But can you control how many miles you run in a day? Yeah, for the most part, as long as you're not getting crazy and you try to run a lot of miles, right? You can control how many miles you run, right? Can't control this. So y always depends on x. The amount of miles depends on what day it is. So you now need to also fill in, for now, until you guys understand these, x is day, y is miles. The y variable is the miles. Okay, since we did this last year, I want you guys underneath to write down your slope-intercept form, y equals mx plus b. Without me giving you any hints, can anyone tell us, based on that scenario, what is the slope-intercept form? Brianna, what do you think? Okay, why? Awesome, good. So he runs 2 miles every day. We know x is day, right? So x is obviously right next to this 2. 2 miles every day. X represents day. So that's one way of explaining it. You also know this is what's changing. The amount of miles that he runs, it's going to increase based on what day it is. The 3 is your B, your y-intercept. He has already done that. He already ran 3 miles this week. So that's already done. That's in the past. That's what he did. Okay? Questions on that part? Okay, before we go to the next part, Madison, can you tell us after day 1, how many miles has he run? Good, 5. Andy, after day 2, how many miles has he run? Good, 7. Nathan, after day 3, how many miles has he run? Good, Kyle, after day 4, how many miles has he run? Good. Eric, after day 5, how many miles has he run? Good job. Anyone notice a shortcut instead of sitting there and doing the mental math in your head? Anastasia, what's the shortcut? Good. You just add 2 here, right? Because the amount of miles that he's running is increasing by 2 miles every day. Okay, he's already run that, but he's running an additional, he's running 2 miles every day. This is something extra that will help you when we get later on in the chapter, okay? All right, standard form. Will, without looking, what is standard form? Sorry. Good job. AX plus BY equals C. I want you to write that form down. And then underneath that, I want you to rewrite y equals 2x plus 3, which is our slope-intercept form. Okay, so now we need to get slope-intercept form into this form. So Marissa, what do we have to move to get this into this form? Good, 2x. How do we get this to the other side? So we need to get 2x to the other side. We're going to do that by subtracting it. So minus 2x on both sides. So we have negative 2x. This y is positive, so plus y equals 3. Anna, what is wrong with the way that that's written? Okay, so we have a negative. A cannot be negative. Anna, you want to try to tell us how to get rid of it? If not, that's okay. Anyone have an idea? How can we get rid of that negative? Alina? If we add 2x to both sides, we're going to go back to slope-intercept form. Now, you don't want to do that because you still need to keep it in standard form. Jared? If we make this 1/2 x, then it's going to be a fraction. A and B cannot be fractions, cannot be decimals. Nathan? Good. You can divide everything by -1 or multiply everything by -1. You're creating an equivalent equation. You're doing the same thing on both sides. You're not changing anything. You're just rewriting it so A is not negative. I normally multiply everything by -1. The same thing as dividing. You can decide what you prefer. After you distribute everything by -1, we get 2x minus y equals -3. That is your standard form. This was our slope-intercept form. Okay, that's all I had to say about that problem. Any questions for me? They're all like this. The only thing that's really new for you is explaining this part and the standard form. Okay? Now, do you have to make this table every single time? No, we're going to do this for a couple just so you understand what's happening in the scenario. Okay? All right, you guys sure you're good? Okay, next problem. And again, stay with me on this one as well, just to make sure we're all okay. All right, number 2 says, Jen weighs 200 pounds and loses 3 pounds every week. What depends on what in this problem? Jared, go ahead. Good. Her weight depends on the week. Or you can get more specific and say pounds lost in a week. I usually try to keep it very simple. Weight depends on week. Underneath that, I would jot down that y always depends on x. How much she weighs depends on what week it is. Maybe she's doing Weight Watchers, right? And you know on Weight Watchers, if you follow your points, that maybe you lose 2 pounds a week, 3 pounds a week, depending on what the process is. Underneath that, underneath the problem, like we did on number 1, please write down that x is week and y is weight. So her weight depends on what week she's on. Okay, let's go to the slope-intercept form equation first. The general form, in case you guys need it, you don't have to write this, is y equals mx plus b. Eric, can you try to tell us what the slope-intercept equation is for this? Close. Okay, can you explain to everyone why is it -3x? Correct. She currently weighs this, But if you think of our graph, think of last year, if you start at 200, your weight's going to be declining if you're following your weight loss program, right? So she weighs this, but the graph is charting her weight loss, how much she loses over time. Brianna? For you guys, no, because last year I told you to always keep it in y equals mx plus b form. At this point in the chapter, I would not mark it wrong if you wrote it as 200 minus 3x, okay? But when we get to the graphing part, it's going to be wrong if you don't write it the right way, okay? Anyone else have questions on that? Okay, so remember, the x goes with week, 3 pounds every week. The 3 goes next to the x term. We knew x was week. You cannot control weeks. That's why x is week. You know y is weight. Most people, if they have control, can control their weight, right? As long as they're not eating a lot of junk food, right? Do you guys have that problem? You just like to eat junk food? You guys do not have to worry about your weight, but for adults, they need to control that, right? Okay, so is everyone okay on why this is set up this way? Okay, let's go to our chart here. Nathan, after week 1, after it, how much does she weigh? Good. Okay, after week 2, Anastasia, how much does she weigh? Good, 194. Alina, after week 3, how much does she weigh? Good job. So what's the shortcut here, or what is the pattern that you notice on this side of the table? Luke B? Good. They're all decreasing by 3s. So again, just something so you understand it. Let's go to standard form. Standard form is ax plus by equals c. Underneath that, please rewrite the slope-intercept form. Okay, Kevin, how do we get this into standard form? You do. How do you get this x to the other side? Okay, are you paying attention? You sure? Okay, add 3x to both sides, goes away here. So you guys have 3x plus y equals 200. Anastasia, is there anything we have to do to that, the way that it's written? Is there anything we have to change? No. Brianna? For these scenarios, yes, because we're starting off setting them up in slope-intercept form. When we get to chapter 5, you'll see equations that will have a number in for the A and for the B. Good question. Anyone else have questions on that? Okay. I want you guys to, hold on, go to number 5. I want you to try that one on your own, and then we're going to come back to the other 2. So go to 5 first. I want you to try that on your own, which means tell me what depends on what, tell me what the x and y are, make a table of 3 numbers, and then also both forms. So just do number 5, and then we're going to go back to the other ones. So we're on 5. Kevin, 5. I would change this to a fraction. But yes. On number 5, I would change the 25 cents to a fraction, in case you didn't already do that. And we'll go over it. Just try the best you can. I want to see where you guys are with this. Money depends on, you said money lost. Money depends on day, though. If you think about if you leave a quarter in your LV card, you're going to, depends on how many times you actually lose it. So money depends on the day. Okay. You told me one of them.
I know, that's because I noticed the pattern.
You noticed the pattern? Okay. So after day 1, you need to find what y is. It's kind of like you're plugging 1 in for x mentally. So negative 1/4 plus 15. You'll write down what that is. For 2, it's like you're plugging 2 in for x. You're finding what y is.
How do you get 1/4?
This 0.25 is 1/4.
Oh, okay.
You know what I mean?
So you do.
So you plug whatever x is, you plug it in for x, and then simplify this to find what y is. That's what I was doing in my head when I was asking you guys. Make sense? Doing okay? Make sure you guys try to come up with a chart. Come up with a chart that has at least 3 numbers on, so that I can make sure that you understand the table. What'd you say? Are you tired? Yeah, I know. I was really tired this morning. I'm a little better. Still tired though. No fractions, no decimals, and standard form. Because in a couple of years I saw fractions and or decimals on your standard form. Make sure no fractions, no decimals on standard form. Yeah. Hey, you got it. Is that negative? Yeah. Good. You got it. What do you mean make it the normal thing? Change it to a fraction. Well, add this first, and then if you don't remember how to get rid of the fraction, I'll talk about it in a second. You know what I mean? You remember? Okay, so yes, that'll be the answer. You want me to check it? Perfect. Even your table's good. All right, let's start to go over it. All right, Kyle, can you tell us what depends on what? Good. Money depends on day. Madison, what is the x variable in this problem? So what does x represent? Good. X represents day, which leaves money as representing y. Is everyone okay on how to identify what's x and what's y? Just give me a little head nod, just so I can make sure. I know you guys had it right, but okay. So money depends on day. Okay, next thing, slope-intercept form. Andy, what did you have for your slope-intercept form equation? Did you say 1/4? Okay. Did you say the negative the first time? That's what I thought. Okay, why should it be negative? Good. If you're losing money, your account or the money you have is decreasing. So Emily currently has $15 and she's losing a quarter every day for some reason. 0.25, everyone's okay with changing that to 1/4, right? You're just converting that to a fraction. If you're not sure, use your calculator, type in 0.25, hit math, enter, enter. Okay. You guys think of a situation of why you might lose a quarter or how you might lose a quarter every day, Nathan? Well, how does that make, oh, because you're paying things off. Is that what you're saying? Okay. Good. Eric? Mm-hmm. Oh, that's a good example. I like that. When I was little, I used to get the bouncy balls out of the things at Giant Eagle. I don't know why. My brother and I liked to play with bouncy balls. Do you guys like bouncy balls out of those machines, or did you ever? Okay. I was going to say, is that just me? Kyle? Really? Skylar? Oh, I'm going to have to ask her about that tomorrow. Just kidding. Luke B. Luke? Not for you. Okay. I thought you meant for you. Okay. I'm glad to hear you're not misbehaving. Well, okay, that's okay. Guys, have you ever go to Aldi with your parents? You know you have to leave the quarter in the cart? I always think of that when I think of this problem. Well, put it in. Thank you. Not leave it. Sometimes I give it to people just because it's easier. But yeah, not leave it. You have to put it in to use the card. Then you get it back. Yeah, sorry. So you're not misunderstanding that. Okay, next thing, standard. Let's go to standard form next. Brian V., what was your standard form equation? Okay, and then what did you get? Okay, yeah, not right. Okay, Brian B., tell me, and I'll stop bothering you. Tell me the first thing you did. How did you get this to the other side? First, move this to the other side. How do you do that? Okay, so add this to both sides. So we have 1/4 x plus y equals 15, right? Okay. Can someone tell us now, how do we get rid of the fraction? Brianna. Good. Multiply everything by 4, kind of like getting rid of the negative, but now we need to get rid of the fraction. This 4 needs to be distributed to every single term, so we end up with x plus 4y equals 60. So Brian V, did you forget to multiply the 15 times 4? Okay. You okay? Anyone have questions on that part? All right, let's go to our chart here. Jared, after 1 day, how much money does Emily have? Good job. Madison, after 2 days, how much money does she have? Good, $14.50. And then Alina, after 3 days, how much money does she have? Okay, is everyone clear on where and how we get these numbers? Okay, are you guys finding this easy? Give me a head nod one way or the other. All right, let's go back to number 3. Yeah, let's go back to number 3, because I'm sure that you guys are going to have questions on this one. Okay, number 3 we're going to do together. Okay, number 3 says, Mary owes $20 for her credit card bill and charges $5 to it each week. Now, before you start to argue, because I'm sure you guys are going to think a different way, some of you, we're going at this from the perspective of how much she owes on her credit card bill. So that money that she owes is putting her in debt. Do you know what I mean by that? We're going from this in the aspect of she owes money, okay? All right, so anyone want to, let's start with x and y. What is the x and what is the y in this problem? Gigi, what's the x and what's the y? Okay, so x is week. What's y? Okay, so what she owes, you could do bill or money owed, whatever you prefer. Okay, so if y always depends on x, we're going to do bill or money owed depends on week. Okay, I want you to write it for now, yes. Okay, anyone want to try the slope-intercept form equation? Luke B? Did you lose it? Okay. Anyone want to try? If I made sense how I explained it. Brian C. Okay, yeah, give me with the numbers though. Or you don't know yet. Okay. Well, and if not, I'll talk through it. Maybe I explained it poorly. That's not what I wanted, but that could work. Eric. Okay, minus. So last year we had a long conversation about this with the 7th graders. Now you can think of this the other way. If you're thinking of it as her bill, you're adding money to her bill, then they will both be positive. So on a test or quiz, if you have it as plus, you just need to make sure you follow through on the whole problem with that because you meant it as, okay, her bill is increasing. I keep it as a negative usually because she's charging $5 every week. So technically she's losing money. That's how I think of it. She already owes $20, so she's going to be losing money is the way I think of it. Does that make sense? Will? Yeah, that's what I just said. If you have both of them as positive on a test, Will, you're good because I can see it from both ends. You just need to make sure that if you're doing both positive, that you're following through on both of these. Is everyone with me on that? Okay. All right, so here's our slope-intercept form. Let's go to standard form. We need to go from y equals negative 5x minus 20 to standard form. Standard form is ax plus by equals c. So all you need to do is add 5x to both sides. So you end up with 5x plus y equals negative 20. Questions on that one? Okay, we're going to save 4 for tomorrow, so flip over to 6, 7, and 8. Okay, so you're going to try 6, 7, and 8 on your own, okay? Do not worry about the table. So here's what I need you to do. I need you to write down what depends on what, okay? Just like I have up here, what depends on what. Write down what x is, what y is. Don't worry about the table. And then question for you. Number 6 says, Judy starts running today, and she is going to run 0.75 miles every day. If someone starts running today, what is the y-intercept? What is b? Let me say that again to see if more of you guys know. If someone starts running today, what is b or what is the y-intercept? Jared? Okay, but what is it? What number? If you start running today, what number is your y-intercept? If you just start doing it today, it's your first time, good, 0. So if you just start doing something today, like in number 6, your y-intercept is 0. I wasn't going to tell you that, but I figure I should probably give you a heads up. If you're paying for something, make sure you have that as a negative. Also, make sure your slope, you convert them to fractions. So 6, 7, 8, do everything besides the table. Does that make sense? Okay, sorry, I know I said you might not have homework. That should not take you too long. Okay, I will see you tomorrow. Good job today.